Hello, good afternoon, friends. So I'm here, quite excited to give a talk. So I would be talking about technology, right? Something that we use in our everyday life, but something that we don't talk about much, and it is something that we require as a human to build connection with other humans out there. So that's called real-time communication technology, right? It's a part of our daily life. Uh, so during our prehistoric time, what used to happen was that it was the communication that helped us coordinate to each other. And when we were able to coordinate, we were able to increase our survival chances. And we were also able to bring more food to our table and distribute it much more better. This is also the core reason, one of the major factor of the evolution of ours. We also know that the money and the crypto that we know is basically a tool to capture the value. And this value comes from the consensus, which is basically people coming over an agreement, a group of people coming over an agreement. This makes real-time communication technology much more critical than ever. Right now, if we see in our Web2 world, there are a lot of applications like Facebook, Instagram, TikTok, Twitter, all of them combined, the social media combined, there are 4.48 billion active users, social media users. And if we compare them to Web3, there are only 84 million active wallet users. And these are basically combined with centralized exchanges also, addresses also, and the decentralized exchanges also. So you can see the ratio, like we are still a lot of problems, the social app that has to be solved. The Web3 adoption is still an unsolved problem. Now to get this real-time communication, basically, how do we bring it over the internet, right? So real-time communication is basically many-to-many audio-video data transferred synchronized at sub-latency second. But like the current protocol that we have, which is like HTTP, TCP, UDP, they are not optimized to do so because many of them operates on request response mechanism and all of those things. So there is a protocol called WebRTC that is actually used to give this RTC functionality in the today's world. But there are a lot of problems with the WebRTC because it was not designed to scale out there. And actually, this led to a lot of problems out there. If you see, this led to like the custom servers to scale out there. And since it requires custom servers, so what happened was that the corporates started accumulating those servers out there. And even on the P2P level, you require this centralized signaling mechanism to actually establish those calls out there, which is the problem. Now, what's happened with this is that basically the user's data goes to a server which is practically a black box. So you don't know what's happening with your data, you don't know what's happening with your privacy out there. And also, you never know like if it's the best performance that they are getting out of the box. And on top of it, the users are actually exposed to rent extractive mechanisms and even the vendor lock-in systems out there. And there are a lot of other problems, but if we go into that, I think we can go. So now we have DRTC. This is something that we were actually working on at Huddle. So Huddle is not just a normal audio video conference. It's incubating this RTC infrastructure of the future. It's called decentralized real-time communication infrastructure. So what is it? I will give you a visualization. So basically, like how Polygon and other are like basically the scalability solutions for layer ones. The DRTC is this real-time communication layer for L1s out there. And what this would enable is that now you can see this Web3 social kind of dApps which require this live streaming, which require this audio video calls, or which require their avatars to chat with each other at real time. Those can be possible with these things. Now, at Huddle, what we did was that basically to get this real-time infrastructure up and started, we took this product-first approach. And with this product-first approach, you can actually bootstart this RTC infrastructure layer out there. So yeah, how did we basically, and another thing that point to note is that what you see is that the token like what happens in generally the Web3 world is that people make token and they dump the token on the community itself. The other thing is that like they make the technology and then they dump the technology on the users itself. It's the same thing, right? But what we need to do is that we need to make a product and we need to make that product valuable. And then once that is valuable, we need to distribute that value to the users and the community. Now, once we are able to distribute wealth, there's higher development among that community members out there. So yeah, at Huddle, what we are able to do is that within a single click, you can see, you can access all of the best of Web3. Like you can live stream, you can record, you can have your ENS name, can have an unstoppable name and lens protocol out there. You can even live stream to YouTube, Twitch, everything out there, all at a single click. So we are also be able to bring this experience to your web application and to the mobile applications also. And these are live. You can just check it out from your App Store and Play Store and start playing around with it. So all of this infrastructure is actually powered by a media infrastructure. This media infrastructure, if you see, talks directly to the Filecoin network to store on IPFS and Filecoin. It live streams to LivePeer protocol to live stream, which is basically one-to-many broadcasting stream, and it has this media routers. Which is made on open source libraries. But on top of this media servers, there are custom algorithms that we have written, such as last and such as dominant speaker identification, codec optimization, and all of those things. So this makes the infrastructure much more robust, and this is a sufficiently decentralized architecture as of now. Now, if you see, like we have spent like a year or 2 year making this architecture much more robust and all of those things. But what we don't want is that the developers out there to go into that same rabbit hole. So what we did is that we packaged all of this infrastructure into our SDKs. Now, using our SDKs, you can have the same capacity that the Huddles app has. So it's basically you can fork the Huddle application and make it on your own. You can just white label it, and you can make other kind of application. You can make Twitter Spaces. You can make Farcaster Spaces. You can make lens calling one-to-one, all of them. You can also make like a wallet address which is calling other wallet addresses out there, and it opens like a huge door out there. If you're building a metaverse, in the metaverse, like the avatars need to chat with the other avatars. So here is where you can use the Huddle SDKs out there. And there are other things also, like the imagination can go wild. Wherever you require this real-time communication infrastructure, you can just plug in the Huddle SDKs and get that up and rolling. These are load-aware, region-aware, globally distributed server. And I would also like to take you the quality that we have actually, what the Huddle, this infrastructure is capable of. First is quality. So we can see like it does 1080p and higher quality out there. So it's much better for the screen share. We have been able to minimize the packet loss, there's less jitter buffer, there's dynamic bandwidth adaptation. And all of this thing we are trying to do in less than 100 millisecond, because that's the best VC experience that we get when we are doing less than 100 milliseconds. So yes, we are end-to-end encrypted also. So if you can see, there is the call going on. So this is a version that a user sees on the left side. And the other version is what if the hacker breaks down into the media infrastructure, that is what he sees. Right? It's an end-to-end encryption call. And even this is how Huddle's media infrastructure actually sees. So your data is actually secured out there. Even like the Huddle servers cannot see other routers, they cannot see the data that you're doing. They can only process the meeting at a super high quality out there. Scalability. So these end-to-end calls, we were able to scale to up to 30 people out there. And here you can see it live out there. But further, activating the last and algorithm. This helps us scale to more than 400 people out there. And this is basically the robust infrastructure that we have got. And further going on, we have also can be horizontal scale. So which means such meetings can happen parallelly out there. So can handle any amount of scale there. So the progressive roadmap. So what we believe is that the decentralization is not a switch which can be like 0 and 1. It's progressive in nature. So Huddle was born in ETH Global Hackfest 2019, which was sponsored by the Filecoin and Protocol Lab. We went into Tachyon Accelerator, and and this is the current product that we have right now. So the DRTC we talked about is the basically the phase 2 part of plans, and there is an app for crypto economics, which is our phase 3 part of plan, and they both would be working parallelly. So DRTC is basically this will make the all the central component into this nodes architecture, and the app for crypto economics would be basically this incentive mechanism for all the apps to work together. What we will realize end of the day where we actually want to get to is basically an open, neutral, borderless, decentralized, censorship resistant, government, community owned and governed real-time communication infrastructure. Yes, so would love to share some of the learnings that we had while building Huddle. So in HackerFest, we actually made it as a P2P mesh, but we realized that there's a lot of problems with this approach. So the P2P mesh was not scalable. After 4 people, like the experience on the user end was not something that can go as a product itself. There's a lot of less security because if in P2P mesh, if any one of the peer is malicious, the whole thing gets compromised. The data persistent, you cannot persist the data in this typical fashion out there. This is the whole reason like the IPFS actually made the Filecoin, which is basically the same IPFS mechanism with an incentive layer out there. Uh, and the other problem is that in this P2P mesh, the other peers can send the malicious or illegal files to other peers because if they are contributing to the network. So again, that's a problem. And we cannot always rely on P2P mesh because they might be available or they might not be available. So they're highly unreliable. What we can do is basically convert this P2P mesh to peer to node architecture. Once we are able to do so, what we can do is that these nodes can become have this macro level feedback, and wherein these macro properties can be decentralized, and they have this consensus algorithm taking care of all the micro level competition that is going on. So this is like individual nodes which are optimizing their self game, but they're competing with each other. But on the overall macro level, they're collaborating with each other. So this makes it very highly scalable out there. And you can always have this security and slashing algorithm. This maintains the quality of service the network has and even the security. So app for crypto economics. So this is something a network flywheel. Many people ask me a question that how the value accrual would happen on the token itself. So if you can see, there are end users and there's a community network effect starts to happen. Once that's happened, your volume of RTC minutes starts to rise. And once that starts to rise, what happens is that people start building application on top of the Huddle infrastructure or the RTC infrastructure out there. This makes your volume of RTC transaction rise. And once that's rise, your basically the token value starts to raise. And investor generally wants an upside exposure to any value that is going up. So they put in the financial capital. Once there is like a financial capital and the token has this both monetary value, the people start to put forward their computational and bandwidth capital, the Huddle nodes, the nodes provider, and in return they get the token itself. So you can see on a global level, like the people are putting in more nodes. So what happens is that the quality increases, the security increases, and the pricing goes down, and the scalability increases with the more the nodes that get acted out there. The app for crypto economics. So in the recent what used to happen was that the incentive layer was only on the infrastructure layer, but on the application layer, the only incentives you have is basically bounties or some other forms of making people to make the apps out there. I think we can have a protocol that can work that has this both incentive layer on the application layer and this has this incentive layer on the infrastructure layer, and there's a dynamic between two that collaboratively makes the whole ecosystem grow. Yes, so would also love to take you to the Metcalfe laws and social network theory, because real-time communication has this value in social network out there. So Metcalfe laws states that in a telecommunication network, the value of that system grows by n square if another node comes into the picture out there. So here you can see in the graph, basically, like first is like one or two user, but as as the node starts to increase, the value of the whole network start to increase, and the whole of the value can be captured into this crypto economics out there. So the perfect example of explaining the Metcalfe law is that suppose you have a mobile, right? So in this mobile, if other person has mobile, the mobile this mobile gains value, right? And so if you're the more the number of people you are able to call within this with this mobile, the more value that the mobile, the whole network has. So for end users, the value increases if number of people and the nodes into that infrastructure start to increase. And this is like a what the Metcalfe and the social network theory actually summarize the, and this is how actually the networks like network effects product like Facebook, Instagram, and all of those things are actually evaluated on the network effects again. So Zoom was able to overtake Skype because what they enabled was that so Zoom only you had to have this email ID to get to a Skype call. But what Zoom did was that even without a Gmail ID, you can do a Skype call, you can do a Zoom call. So this led to more network effects out there. But at Huddle, what we are doing is that you can have this like non-Zoom account, and you can also bring in this crypto primitives out there, which is on the rise. And this is again leads to this network effects out there. Yes. So again, I would highlight some of the problems in the web RTCs out there. For a web RTC to take, there's like four things that goes on. One is first step is signaling. Other step is like you need to connect the secure out there. First is signaling, then is connecting, then is securing that whole infrastructure, and then you start communicating out there. For signaling, you need to have these servers out there, which are centralized in nature. Uh, so again, so in this, if you can see, like the signaling is centralized, but if you can convert these servers into a nodes, and these can be like multiple nodes which are like chatting with each other. So your SDPs you can now send to this node, and these nodes can gossip around this SDP, and whichever peers required that SDP, it can subscribe to that SDPs out there. So this is how you can like remove this single point of failure out there. Now we have realized that like you can use this not just for like putting out the SDPs. You can use it for both synchronous communication, and you can use it for asynchronous communication, right? So what is synchronous communication? So if you had used Slack, right, there is a Slack button out there, so which is like many people coming at call at that point of time. So Zoom meeting is a synchronous out there, but Discord and Slack, they are asynchronous communication. So with this mechanism of divergent, right, wherein you are divergent node, wherein you can use this infrastructure for signaling to attain the async communication, and simultaneously you can use an infrastructure to have this async communication capacities out there. So again, what we did was that this is the end-to-end encryption that we had solved out there. It used NaCl algorithms out there from the private public keys of the user itself. So even this signaling mechanism is end-to-end encrypted. And yes, so we have packaged this divergent node into the divergent SDKs. Now you can see that this is a WhatsApp clone made on a Lens protocol, and you can see a starter Huddle that uses Huddle's media infrastructures, Huddle's SDKs, and all the chat SDKs is like the divergent SDKs out there. So you can see we have achieved both asynchronous capacity of communication and the synchronous capacity of communication. And developers can have this imagination and can build this any kind of applications out there. And the DIDs, that is basically a Lens protocol out there. Yes. So like now coming back to DRTC, like what is actually a DRTC infrastructure? So if you see like UPI, right? The UPI is a fintech infrastructure wherein this Bhim app, PhonePe app, and Google Pay app was made. Similarly, this DRTC layer is like enables this is the spine of this Web3 social app, upcoming Web3 social app. So now you can have this decentralized TikTok, you can have this decentralized Twitter, and you can have another kind of new primitives app, which I think would be possible, which is like the social app and the financial merger kind of apps out there. Because think of like a social, a Twitter leveraging the DeFi infrastructure out there, and this can blow up. Like we just need to like productize that very well out there. But for the start, I think the cloning of the existing Web3 infrastructure would start to happen, like clone of Discord, clone of WhatsApp, clone of Twitter, clone of LinkedIn. They would start to happen, and they would require this synchronous capacity and asynchronous capacity also. And even in the metaverse, like all the NFTs, they have these games, right? The MMORPG system, the massive multiplayer online system, all of this requires this real-time infrastructure. Yep. So the Huddles infrastructure is already powering a lot of other applications out there. So this is the whole ecosystem that Huddle is actually powering. So there's like schedulers, there's like accelerators, there's like metaverse spaces, there's messagings, there's Web3 ed tech, there's wallets, NFT communities, social. And I think this is a blank canvas, which is like yet to be filled by other entrepreneurs and other people making new innovations out there. Yep, thank you. This is Susmit, and this is my barcode. If someone wants to follow, yep, thank you.